In this video, I will describe 6 steps that can be used to improve an Agile backlog. Hello, my name is Neil Potter, and I help Agile teams go beyond the basics of Agile software development. Please click below to subscribe for future videos. Agile teams rely on backlogs to define scope and features in their solution. In many cases, backlogs are ambiguous and errors can slip into sprints, causing later rework. In this video, I will describe 6 steps that can be used to make a better backlog. So before we discuss the 6 steps to improve a backlog, let's first define a backlog and a requirement. A backlog is a collection of requirements, typically in a document or a tool, and it is a list of the work to be done but not committed to yet. It's a placeholder for requirements and data. So a requirement is one item in that backlog, and a requirement is typically stated as a condition or capability that is able to address a customer's or a user's problem or achieve their objective. So if we were a user to a system like Amazon.com, we have a need to add things to a shopping cart. We have a need to do payment, modify shipping, track shipping, etc. So there are problems we've had in the past in ordering stuff. So the requirements would address those problems. And there are goals we want to achieve, like getting the items in the cart and shipped and paid for, which we want to achieve too. So the backlog or the requirement basically describes the end user's perspective of what they would like to see in the software to help them do that particular job. Now, a lot of backlogs tend to be very ambiguous, actually very ambiguous indeed, and not have a whole bunch in them. Teams going to get busy or stressed to go code something, and there isn't much in the backlog at that point. So I think target D would be pure guesswork and would lead to a lot of rework downstream. Now target A, the opposite of that, a perfectly clear backlog, is also probably impossible to achieve. It is very rare for a customer to tell you exactly what every button should do, how it should look, and how it should function. Very few people can think of all those details one time and put it into a spec. So I think our goal is to have target B and C defined, either target B or C. Target B is where everything is in the backlog, but may not be particularly clear. I'm going to use the discussions, the backlog review, and some of the steps we're going to discuss today to clarify the backlog. And target C examples where a part of the system is very well defined. The customer knows exactly what they want for a part of it, but the rest is ambiguous. So we use the feedback loops of Agile to clarify the ambiguous parts of target C. So I think target D is kind of a waste of time, a lot of coding and guesswork, and target A is kind of impossible to achieve, and target B or C would be a good workable solution for the backlog. So the first step of the backlog improvement is to use a single sentence format or table format for the requirements. Now this backlog here is a fairly standard Agile backlog. It basically has a list of one-liners, one-liner user stories, and the format is, as a user, I want to have a desired action achieved. So I think that's a very good first approach to use for a backlog. That is that the user has a need for the software to solve a problem or achieve a goal, and that the user story helps define what that is. And then if you code to that correctly, then the user would have a solution they could actually function with. Now, some people, when they write their user stories, add the definition of why to the end of the user story. They put a comma why at the end here. And that can cause ambiguity and redundancy in the user story. So for example, as a purchaser, I want to add products to my shopping cart. And then they say why? Because I want to buy something or have it shipped to my house, or have it gift wrapped. And so when they put a why at the end of the sentence, it can get the user story very complicated and very fluffy and ambiguous. I recommend not doing that because it could become complicated. If you have a need to add a why to the sentences to explain to the team or the developer the bigger picture of what we're doing, what I would do is group together a few user stories and then define one why category at one time. So maybe the idea is to purchase, or ship, whatever the particular why is, and that is one Y added to the block of user stories. That is often called a theme in Agile. So basically it's a label structure which you add one time to a group of things, and then the theme is basically the Y, stated clearly one time, and the user stories kind of exist below that to define the particular user tasks the user wants to achieve. So when I see teams do Agile and I look at their backlog, the backlogs tend to be very messy. I call this a mumbo-jumbo backlog. What happened here is the team learned how to do Agile, and they learned the user story format, but they really had no place to put their to-do list. So they ended up using their backlog placeholder for their to-dos. And then bit by bit, they kind of felt like they needed to have a user story format, and they took their to-dos and then added a user story format to it. So for example, as a developer, I want to write code for the GUI next week. As a developer, I want to write code for the cart next week. It makes no sense whatsoever to write a to-do as a user story. This is just kind of a pretend backlog now because it looks like a backlog because it's in the right format, but it's actually not a backlog. So really in Agile, there are two backlogs. There's the product backlog, and that's basically where the requirements go, the user stories. So you want to keep the requirements in the product backlog, and you want to keep the to-do list in the sprint backlog. So most tools will have a backlog for requirements and a task list or a subtask list feature for the to-dos. So do look at your backlogs and check they are really requirements focused versus to-do list focused. Now, the next thing is to look at the backlogs, and then if you have a very complicated user story, even like an epic, is to kind of learn how to break them up into pieces and make them a lot more specific. Let's suppose that we asked a customer to define a requirement with us, and after the discussion, we ended up with this paragraph just here. This is the best they could come up with to really clarify that type of requirement. So the system should allow entry of data items relevant for customer payment, or allow a user ID to be entered to charge the amounts to. If an ID is used and there is insufficient customer account funds, then either request a credit increase or notify the account is overdrawn, and flag the account as credit overdrawn, OD, and then email a receipt of the transaction. So that is the typical long, wordy version of a requirement you may get after the discussion with an end user or a business analyst. And although it may be accurate, it is confusing to kind of understand and code to. So what I recommend is we take that paragraph or that complicated user story and then parse it out into pieces and make it more detailed. So for example, 1.1, we have a user selects pay with credit card or ID and password. And 1.2, we enter either A, the credit card, or an ID and password. And step 3, if option B is selected and insufficient funds in the account, then we request a credit card increase. And then step 4, if the credit card increase option is not selected, then notify the account is overdrawn. So you can see now we've taken the paragraph long user story requirement and then broken it out into pieces and make it more specific. This may take a little bit of work, but it is better to do it now for maybe an hour than to guess downstream and code incorrectly. Now, if the requirement you're describing is of a critical system, like a medical device, or where there's a financial or a major impact if we get it wrong, you might decide to take the details here and then redefine in a table format to clarify these options. So for example, if we look at the sentence here, we can maybe elicit there are 4 conditions that could occur, okay? And that those conditions also have a true and a false state. So if we put the conditions here, the 4, and the requirements, true or false, we can then flag in the table which ones are true, which ones are false at any particular time. And then for those combinations, we can define the outcome. So for example, there are 3 options for the outcome: payment accepted, account flagged as OD, overdrawn, and email receipt. So by clarifying the conditions in the sentence and then defining a true or false state for those and the combinations of those true and false states, we can also, for a particular column, define what happens if we have a true and false and what the outcome is likely to be. This is a great way to then detect ambiguities and mistakes in the requirement, where there could be up here a lot of errors that have not been particularly well thought out yet because they're very complicated. And the table helps you kind of figure out those options and where you really want to define the requirement better. So you may have one user story that is complicated, but below that you have the details defined in either the table or the truth table down here. So step 2 is to include all types of requirements. Over the last 15 to 20 years, I've noticed that teams have focused primarily on the user story type of requirement, but there are many other types of requirements to put in place in the backlog. So here are some example requirements types that go along with user stories to add to the backlog. We have our regular user story here. That's what our backlog typically contains. And below that, we have our use case. So a way to define a user story in more detail, simply but concisely, is to use a use case that defines pre-post conditions, normal flow, and exceptions. Again, good to break up the ambiguity or assess the risk of a user story. We have external interface requirements. So every system has to interface to something, either the user, data, a machine, a computer, and therefore to define those interfaces, that's added to the backlog. Business rules. There are some requirements that are musts. If you exceed or violate the business rule, it could cause a major problem downstream to the user, either financial loss, death, injury, whatever. Quality attribute. We expect systems to kind of function correctly for a period of time, and therefore to define that is called a quality attribute. There could be many constraints. Constraints with being compatible with older systems, older hardware, memory constraints, displacement constraints, user skill level constraints, and then data definition. So every software has data, particularly user data or machine data, messaging data. The format is essential to make it function correctly. And then conditions like functional requirements. For example, if the pressure exceeds 40 psi, then what do we do? If you put your foot on the gas pedal and the brake at the same time, then what kind of happens? And then a business requirement, the bigger picture, like an epic of why we're doing this particular system. Now, I skipped over here the solution idea. When you go through the requirements, you might decide that some of the requirements in the backlog are actually not requirements at all. There's just solutions or suggestions, like using AI. That probably is not a requirement. It's a suggestion. We could use AI, but there could be other ways to do it too. So number 3 is to only define each requirement once with no duplicate information. So when people do their backlogs, it is very easy to duplicate requirements because they're very similar in nature, similar features, similar user stories, similar output, similar input. And therefore, as we then write more requirements or more user stories, we're going to copy and paste a previous one, modify it a little bit, and then going to define it again. So then when there's a change, like an output change or an input change, then we have to go to every requirement and then modify those requirements. That could be very error prone to do that correctly. So to overcome the issue of redundant or duplicate requirements, we could have a table format and then define the requirements one time. So epics, for example, are defined one time and labeled. User stories are put in there too. Quality attributes like performance and throughput, like respond in 2 seconds or get through 10 transactions in a millisecond. Again, that could be a common requirement. We define it one time, label it. Any user story that needs to refer to that refers to the label. And then if that changes, we can then modify the requirement one time in the table. And business rules, similarly, business rules such as don't exceed 40 psi or don't exceed 10 transactions per hour, we can then define that one time. We can use that particular label in any user story that needs it. And then if it changes, we can then modify the requirement one time. So this is a way to then tidy up the backlog and then look for duplication and define every item one time and then refer back to the label for the use of that item. Number 4 is to trace requirements to test cases. So if we build a system and we are mapping back to the user stories and the requirements in the backlog, we want to make sure that the system actually functions correctly before we then deliver it. and that we actually have finished the work ourselves. We need to know that as a team, that we are done. So tracing is a way to kind of prove doneness to the team and to the customer before we ship. So if we use a table format for the requirements, and then they're broken out into unique requirements and clearly stated in a table format like this, we can then add a test case trace to the last part of the table. Now this could be many test cases or one test case, but now every requirement is unique, uniquely defined, and then we have a unique set of test cases that go along with that. So when we say we are done with our sprint or done with our release, we can then refer back to the test case for that particular item and know that that particular requirement has been tested uniquely by that test case. Number 5 is to remove specific ambiguous words. So when we describe a backlog in a language like English or Chinese, it is very easy to kind of use ambiguous words in the backlog that we then have to kind of suffer through or kind of figure out downstream. So one of the backlog checks we want to do is for these ambiguous words. Now, a long time ago, there was a tool by NASA called ARM. And ARM was a tool that kind of ran to read documents, backlogs, Word documents, etc. And it would look for keywords that were being used in the spec or the document or the backlog that were either positive, keep these as good ideas, or negative, these are ambiguous. Now, that tool has been discontinued a long time ago, but the concepts are still out there on the internet, and I've just kind of summarized them here in a couple of slides. So the positive side, we do a search on the backlog for these kind of keywords here. They're called imperatives. They are good things to have in a spec or a backlog. Similarly with these ones here, these are the further definitions of a user story that we may have in the backlog. So if you search for these items and you found them, you want to keep them in the spec or the backlog because they are signs of clearly defined requirements. So some searching on a backlog could also find these negative or ambiguous words, can, may, and optionally. If you find those, you may want to flag those just to be kind of repaired in the backlog. They could lead to a lot of guesswork downstream by the developer and by the team. Similarly, weak phrases, adequate, be able to, normal operation, timely response, easy to kind of use. Again, these could be key indicators where there could be ambiguity in the spec or the backlog, and therefore you can kind of detect them early on in the backlog and have them repaired. So if you can write a script or a piece of software to kind of read the backlog and look for these keywords, then you can clean up the backlog very quickly from some of the ambiguity. Now, when teams do their backlogs, they tend to leave things in there as placeholders, which is a good idea for Agile because you then want to figure out the placeholder later on when you have more feedback and data from the user. But these should also be searched for. TBDs, TBSs, TBEs, to be defined, to be specified, to be explained, for example. These are placeholders that may end up in the backlog and stay there. If you can search for them, you can flag them and determine which sprint you want to repair them in going forward. To have them in there in a sprint then just leads to more guesswork as a team. So step 6 is to review the requirements thoroughly more than grooming. So grooming is the name given to the activity in Agile to clean up the backlog before the sprint. Typically the team discusses it, clarifies issues and whatever, and they're going to reword things if they need to. But usually grooming is very rushed, not particularly thorough, and allows for many mistakes to be left in there, which then flow to the iteration. And then the developer and the tester has to kind of guess what that word or the user story actually means. Now, I go to China a lot to do consulting, and this is a picture of a signpost in southern China. And you can see a keyword missing here and there can cause major ambiguity and problems downstream unless caught. So a way to make grooming a bit more thorough and detailed is to adopt inspection, or another name is peer reviews, where it's a bit more detailed and thorough and careful about looking for mistakes in the backlog. Here we have a team put together. It could be the developers, the product owner of the backlog, and maybe other experts that can help you understand the backlog and clarify issues. It could be virtual or in person. Either way works just fine. We have epics to look at, to compare against. We have the backlog itself. We may define a standard of what a good user story should be like. And maybe some of the ideas in previous slides can be used. And maybe a common errors checklist. We can build that up over time. Common mistakes made in the team's backlogs over time that can be used to kind of find those mistakes quicker in subsequent backlog activities. So the team spends maybe a couple of hours going through the backlog to clarify stuff in it, and they can basically do a line-by-line kind of word-by-word check of the backlog. When we do it, we log defects and questions. We don't solution or come up with solutions for these things yet. And by not solutioning right now, just kind of logging where the issues actually are, we can achieve a speed typically of 1 to 2 defects per minute. So the team is basically every minute discussing or logging down maybe 1 or 2 items or issues and problems in the backlog. And then later we can have the product owner and team go prioritize and then fix those things later on. So it is a very quick but very thorough line-by-line check of the backlog to find ambiguities, particularly for the items of the backlog for the next major sprint coming up before they do their sprint. In summary, developing a better backlog is not conceptually difficult, but does require some time to do it. You should find every hour spent on the backlog will save at least 1 hour or more downstream. Thanks for watching the video. For more help on these topics or your Agile implementation, please see the links below.